At the Hanover plant, home to Volkswagen commercial vehicles, production begins in the press shop. The process starts with large steel coils. Inside the massive press hall, overhead cranes carefully lift and position these heavy rolls with precise, controlled movements. From there, the material moves into the core of the operation, the servo press line. This advanced line operates with 6 presses and fully automated handling systems. Metal blanks are fed into the line, aligned, and transferred through each forming stage in a perfectly synchronized sequence. With every press stroke, the flat metal gradually takes shape, gaining depth and definition until it becomes recognizable vehicle body panels. The entire process is closely monitored in real time from behind glass control rooms. Operators supervise the system through digital screens while the machines run continuously below. Precision here isn't just about force, it's about exact timing, consistency, and constant oversight. The line is designed to deliver both high speed and consistent quality with every panel produced. Once forming is complete, the finished parts exit the press line and move into the next stage. Robotic systems and automated equipment carefully position them, while additional stations prepare the parts for stacking and transport. What started as a simple steel coil has now become a fully formed component, ready for body construction. The panels are then stored in transport racks and collected for the next phase. Forklifts move these containers across the hall, carrying large stamped parts such as side structures to the body assembly area. This is where the distinctive shape of a Volkswagen van begins to take form. In the body construction area, the process starts with the lower body. The floor structure is placed in a carrier and secured at precise reference points. Then, ABB robots begin the first joining cycle. The side structure is positioned in its own fixture, where intersections, reinforcements, and outer panels are held in a large angled tool while robots work along the joints and connection points. At this stage, the robots are not welding, they are dispensing material. A nozzle follows the joint lines, applying a precise bead of bonding material along the flanges. This process, known as bonding and sealing, is carefully controlled to ensure the correct path, amount, and shape of the material. The substance used acts as both an adhesive and a sealant. Its role is crucial. It seals joints, prevents moisture from entering, protects against corrosion, and helps reduce noise and vibration in the finished vehicle. After this step, a heavy-duty robot lifts the large side assembly and rotates it into the next position. Next comes the framing stage. Here, the side structure is aligned with the floor and the rest of the body to form a unified structure. Large fixtures hold everything in place, while multiple robots move in from different angles to begin joining the sections together. At this point, the structure transitions from separate subassemblies into a complete body in white. Following this, the body moves through dense multi-robot welding stations. The shell is clamped securely, while additional spot welds are applied around the roof, side openings, and key structural areas. This stage ensures the body achieves its required strength and dimensional accuracy. The focus now is not just joining parts, but locking in the final geometry of the entire structure. Once welding is complete, the body leaves the main robotic area via an automated transfer system. It passes through enclosed conveyor and buffer zones, with all major structural work finished. At this stage, the vehicle shell has taken its full form. The floor, sides, roof, and openings are all in place. The body in white then enters a manual fitting area. Here, the front fenders are prepared in sequence racks. An operator positions each panel at the front side of the body using an adjustable support fixture to ensure proper alignment, height, and shape. The next step involves installing the side sliding door. Because of its weight, a guided manipulator supports the door during installation. The operator carefully positions it, aligns it with the guide rails and hinge points, and secures it while the manipulator keeps the load balanced. The final step in this stage is functional adjustment, ensuring that all fitted components operate smoothly and meet quality standards. The sliding door is carefully moved through its full range of motion and checked in the closed position. At this stage, the operator ensures the door moves smoothly, the latch engages properly, and the panel aligns flush with the surrounding body surfaces. Next, the vehicle moves into the paint shop. Here, robotic applicators apply the first sprayed coating across the outer body and inside openings. This layer, known as the primer surfacer, creates a smooth and even base for the final color coat. Robots follow precise pre-programmed paths along edges, curves, openings, and large panels to build a consistent coating before the body advances to the next stage. The process then continues at the seam sealing station. Robots apply a carefully controlled bead of seam sealer along important joints between body panels. The first robot works inside the body shell, reaching through side openings and following inner seams with accuracy. It lays a continuous line of sealant along overlaps, welds, corners, and formed edges. After the inner seams are complete, attention shifts to the outer seams. Another robot applies sealant along the upper side joints and roof areas where external panels meet. These visible seams must be sealed neatly and evenly before the body progresses further into the paint process. By the end of this stage, all key inner and outer seams are sealed, protecting the structure at critical points and preparing it for the next steps in painting. The body then passes through a manual seam sealing station. Here, workers handle areas that are difficult to reach with automation. Using brushes and hand tools, they carefully seal roof edges, door openings, and other exposed joints. In some cases, additional components like sealing inserts are fitted before sealing is completed. A handheld applicator is used to apply fresh sealant, which is then smoothed and shaped to achieve the final finish. Technicians also install anti-vibration pads on doors and floors and fit plugs into stamped openings in the body. Before the two-tone paint process begins, the vehicle enters the manual masking stage. Workers carefully apply masking tape to define the paint separation line along the roof edges, pillars, openings, and panel transitions. In tighter areas, the tape is precisely trimmed and pressed into contours to ensure sharp, clean lines during painting. Once the edges are defined, the roof and upper sections are covered with protective masking film. This film is spread across the body and secured with tape, ensuring that previously painted surfaces are protected from overspray during the next coating stage. The masked body then moves into the spray booth for the base coat application. Robots equipped with rotary atomizers apply the color layer in smooth, controlled passes across the front, sides, and edges. The goal is to achieve even coverage and a uniform finish across all exposed surfaces. After painting, the body exits the booth and continues along the conveyor system. It moves toward the next stage of the paint shop, where the coating will be dried and cured. With painting complete, final assembly begins as the finished body enters the trim line. One of the first components installed is a large molded insulation piece at the front cabin, which will later sit behind the instrument panel. At the start of this stage, the front door is temporarily removed again. A guided manipulator supports the door while the operator detaches it and moves it aside. This step provides better access to the interior, especially the front cabin and side openings. Inside the body shell, technicians continue installing components around the bulkhead and side structure. At the next station, smaller interior parts are added using parts supplied from nearby bins. Finally, the vehicle moves into the glazing station, where window installation begins. A robot equipped with vacuum grippers lifts a large glazed roof module and rotates it into position above the vehicle's roof opening. A second handling system then takes over, lowering the module smoothly and evenly into place. The installation must be extremely precise, ensuring the glass panel aligns perfectly along the entire edge of the roof opening. By the end of this step, the vehicle body is fitted with its large roof glazing component. Next comes one of the most important stages in trim assembly, cockpit installation. A fully pre-assembled instrument panel module arrives at the station on an automated manipulator. Unlike earlier steps, this process does not require manual guidance. The system independently moves the cockpit module into position, aligning it with the front opening of the vehicle at the correct height and angle. The module is then carefully guided into the cabin along a controlled path. It is positioned precisely against its mounting points on the front structure, where it will later be secured in its final position. The same automated process is repeated for each vehicle that passes through this station. This is a highly precise operation. The cockpit module must align perfectly with the body opening, mounting structures, and surrounding trim components to ensure proper fit and finish. The process then shifts to powertrain assembly. A completed module carrier arrives at the station on an automated platform. The first manual step focuses on installing a routed line along the upper side of the assembly. A worker carefully positions the component, aligns it with its mounting points, and secures it into brackets and supports. This requires careful attention, as the line must follow its exact path to avoid friction, twisting, or interference with other components later in the process. The next stage takes place at a preparation fixture. Here, a worker arranges a pre-assembled cable and line harness into a specially shaped holder. Each branch is spread out, positioned, and secured into its designated guides. Protective coverings, clips, and attachment points are organized in the correct order before installation. This step ensures proper routing discipline, meaning the harness leaves the fixture fully organized, with all branches clearly separated and connection points easily accessible. Once prepared, the module enters an automated station where an ABB robot takes over. The robot lifts a large support frame carrying the harness and its attached lines, preparing it for integration into the assembly. At the next station, manual work resumes. Focus shifts to the upper section of the suspension assembly. A worker uses a suspended power tool to secure the top of the spring and damper unit. The tool is positioned vertically and held steady during tightening to ensure proper fastening. This step requires controlled force and alignment, as the upper mount must be secured accurately while the assembly remains fixed in place. Two workers then continue working on the same unit. They handle a large multi-branch wiring harness located at the top of the drive module, carefully positioning and preparing it for connection. Above them, an ABB robot operates over the combined electric drive and battery assembly. Using a multi-spindle fastening tool, the robot tightens several bolts simultaneously. This synchronized process secures the drivetrain module to the battery module in a single automated cycle, ensuring all fastening points are tightened evenly at the same time. Manual assembly then continues on the upper section. Two workers stand on opposite sides of the unit, preparing and carrying out the next steps around the drive system and electrical components mounted above the battery. One worker uses a suspended vertical power tool to fasten an upper connection point, carefully aligning the tool and maintaining steady pressure during tightening. At the following station, additional assembly work is carried out. A worker uses a cordless tool to secure smaller fasteners while managing a set of orange high-voltage cables. These cables are lifted into place, routed carefully across the assembly, and secured along their designated paths. Each branch is positioned into guides and support points, and the connectors are aligned and attached to their corresponding locations on the electrical system. The process concludes with detailed routing and final connection of cables across the top of the fully assembled battery and drive module, ensuring everything is securely installed and correctly positioned for the next stage. Volkswagen manufactures the ID. Buzz at its main plant in Hanover using the MEB electric platform. The key drive system components for the ID. Buzz include the battery system and axle assemblies. At this stage, the body shell arrives suspended on an overhead carrier. It is still an empty structure. The front section is open, the wheel housings are unoccupied, and the side openings remain clear. The carrier moves the body into the upper level of the assembly line, positioning it above the marriage station. The shell advances slowly until it is perfectly aligned over the prepared module below. Held securely by its overhead frame, the body is carefully centered before the joining process begins. Below, the lower module is already fully assembled. It includes the flat battery pack mounted within a carrier, along with the axle, suspension system, brake discs, and key underbody components. As the process continues, the battery module is raised into position between the side sills and underfloor of the body. At the same time, the wheel arch areas align around the suspension and braking components already fixed to the lower structure. The two large assemblies, the body and the lower module, are brought together with extremely tight precision. This step is known as the marriage, where the upper body is carefully lowered and joined with the drivetrain and battery system below. Once the body is fully seated onto the lower module, the newly combined structure moves forward along the production line. The process is then repeated for the next vehicle: positioning, aligning, lowering, and joining. After this stage, the bodies leave the marriage station still supported by the overhead carrier, but now transformed. They are no longer just shells. They now include the running gear and battery system, forming a complete rolling structure. This marks a key moment in electric vehicle production, the transition from a painted body shell to a fully integrated vehicle platform, ready for further assembly. Work then begins at the front end of the vehicle with the installation of thermal system components. A worker places a compact high-voltage front-end module into the short nose section of the vehicle. The unit is carefully positioned on its mounts and connected to rigid aluminum lines and other electrically powered front-end systems. On the MEB platform, many auxiliary components are housed in this front compartment. This stage prepares the thermal management and service systems before larger front-end assemblies are added. Next, manual preparation takes place at the front of the vehicle. A worker uses a power tool to secure mounting points on the lower front structure, which will later support the bumper reinforcement assembly. At the same time, nearby components are checked and cleared for installation. The body then moves into an automated station where a large handling system installs the front bumper reinforcement. The unit is precisely aligned with the front structure and fastened into place. After the automated step, a worker completes the process by securing additional fasteners and checking the side mounting areas. The vehicle then progresses to the headlight installation area. Workers position and secure mounting points around the headlight openings and continue along the upper front structure that connects both sides. This is a highly detailed step. The headlight units must be installed at the correct depth and angle to ensure proper alignment with the rest of the front-end components. The left and right headlight assemblies are then further adjusted and secured along their upper and inner mounting points. Meanwhile, another worker operates within the central front section, tightening brackets and support structures while the lower front area remains accessible. At this stage, the front end is still open, allowing easy access to the headlight housings, mounting points, and cable routing paths. Once the installation is complete, the lighting system is powered on for testing. The white LED light signature, the horizontal light strip between the headlights, and the amber indicators are activated in sequence to verify proper function. Volkswagen equips the ID Buzz with full LED front lighting, with IQ light technology available across the model range. With the lighting system active, final adjustments and tightening continue around the upper front section. At this point, the front carrier brackets and headlight units are fully installed and ready for the next stage of front-end assembly. If you are visiting my channel for the first time, please subscribe and don't forget to press the bell icon. For the ID Buzz, the front bumper is installed as a complete pre-assembled module. The painted bumper already includes its lower insert. Two operators work together to position it accurately, carefully aligning three key areas: the upper mounting edge, the side connections to the fenders, and the lower locating points. The bumper is first placed onto its guides, then held under slight pressure while its fit is adjusted to match the surrounding body panels perfectly. At the rear of the vehicle, interior work begins before the tailgate is installed. The process then moves to the tailgate fitting station, where a large fixture brings in the fully assembled tailgate with its glass already installed. The fixture holds it in precise alignment with the rear opening. The tailgate must align correctly with its hinge points and sit perfectly within the frame before the fixture releases it. Inside the vehicle, the upper rear mounting points are tightened manually using a cordless power tool. Once the inner panel work is complete, the tailgate is lowered and checked in its closed position to ensure proper fit and function. Next, the process moves to wheel installation. Fully assembled wheel and tire units arrive on a roller conveyor, each already mounted on its rim and positioned in a consistent orientation for installation. A handling robot takes over from here. It lifts a wheel from the conveyor, rotates it into the correct position, and brings it toward the wheel hub. The robot carefully aligns the wheel, ensuring it sits perfectly flat against the hub surface. This alignment is critical, as the wheel must be properly seated before fastening begins. Once in position, another robot equipped with a multi-spindle tightening tool secures the wheel. Instead of fastening one bolt at a time, multiple fasteners are tightened simultaneously in a synchronized operation, ensuring even pressure and precise attachment. The same process is repeated for each wheel. Once complete, the ID Buzz now has its full running gear installed and continues along the assembly line. The vehicle then moves forward on lift platforms toward final inspection and finishing. The first check focuses on body panel gaps, particularly around the rear side openings, ensuring consistency and precision. Inspection then continues inside the front cabin. A worker examines the fit and finish of interior trim components around the A-pillar, roof lining, and upper windshield area. In the passenger section, the rear seats are checked next. After that, the luggage compartment is fitted with a coiled cable set, which is placed neatly into the rear load floor area. Attention then shifts to the exterior finish. A worker cleans and inspects the side glass, then moves to the front of the vehicle. Here, the painted front panel, emblem area, headlight surrounds, and leading edges of the body are carefully wiped down and checked by hand. Finally, the completed Volkswagen ID Buzz vehicles move along the inspection lane in a range of exterior colors, ready to be delivered to dealerships.